Actually, the Bowen's reactionary series illustrate the relationship between the temperature. That means at the temperature at which the minerals get crystallizes in the magma chamber. So it is decides chemical composition and mineral structure. So that is the answer for this question actually. So then coming to the which of the following mineral is not part of Bowen's discontinuous series. Discontinuous series means there is no linkage between the minerals that are crystallized. So that happens to be on left hand side in the Bowen's reactionary series. So left hand side. So here I'll just give you pyroxene. So biotite. Pyroxene is a group name for a mineral. The example is agate, is the mineral name. So biotite mica. So amphibole is a dark colored mineral. It's a group name. Once again, hornblende is the example for this, the group member. And then plagioclase. Consider which of the following minerals is not part of the Bowen's discontinuous series. So all the first three are continuous series minerals. They are not continuous series minerals. The first three are not continuous series minerals. And the last one, plagioclase, is a continuous series mineral. So not part of Bowen's discontinuous series. Pyroxene, biotite, amphibole are discontinuous series. So plagioclase is not part of that series. The answer is plagioclase. Plagioclase feldspar. So is the correct name for that. So this is what I just shown you the previous day also. Just look at this. This is the discontinuous series starting with olivine. So pyroxene, then amphibole, so then biotite mica. And you can see that continuous series are isomorphous substitution group minerals starting from anorthite, that is calcium plagioclase. So then comes the calcium sodium plagioclase because there is a substitution of some amount of calcium by sodium. So that's why we say that calcium sodium plagioclase. So then the next one is sodium calcium plagioclase, where the...
Excuse me, sir.
Yes, please.
Sir, the question you are explaining is not on the screen, sir.
Okay, that's what I just asked. Whether now you are seeing this?
Yes, sir.
Okay, most probably if I go to slideshow, then it's not visible like previous class. Okay, so this is the question: which of the following mineral is not part of Bowen's discontinuous series? In case of Bowen's reactionary series, what he has identified? He has identified two series. One is continuous and another one is discontinuous. Discontinuous series are also known as ferromagnesian mineral series. So whereas continuous series are also known as isomorphous substitution group minerals. So here the continuous series minerals start from anorthite to albite. Discontinuous series start from olivine, ends with biotite. So now we have pyroxene, agate, so biotite, so mica, amphibole represented by hornblende. So they are all part of discontinuous series and ferromagnesian minerals. So hence the correct answer is plagioclase. Clear? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay. So now you just look at this. This is what I just explained in the previous class also when I took. So this is the Bowen's reactionary series. This side series that is left, so is the discontinuous series, and they are all ferromagnesian minerals. Whereas this is continuous series or isomorphous substitution group minerals. So there will be a number of questions on this. Okay. So once all the elements, the chemical composition of the magma, so wherein the crystallization has utilized sodium, calcium, so and the iron, aluminium, magnesium and other things, then we are left with silica, potassium and others, so leading to the formation of potassium orthoclase feldspar, so muscovite mica and quartz. Okay. For a given mineral, the physical property which displays the greatest variation is color, luster, hardness, streak. So some of the physical characteristics of mineral or properties of minerals do not change, while there is a lot of variation with respect to color. Hence, color is not used mostly for identification, except in case of idiochromatic mineral. I did mention about this word in the previous class too. Idiochromatic minerals having a single color. So I have given example of sulfur, yellow color, and allochromatic minerals. So there may be rosy quartz, milk quartz, smoky quartz, all those things. And I have given why there is a change in color in a quartz also because of the contamination. The chromopores may be present in those in small packets. Okay, all primary silicate minerals excepting phyllosilicates have silica tetrahedra, aluminum octahedra, both A and B, all of this. I just leave for you, one of you can quickly answer me. All primary silicate minerals excepting phyllosilicates have silica tetrahedra, aluminum octahedra, both A and B, all of these.
All of these.
All of these, sir.
Okay, read the question. All primary minerals excepting phyllosilicates. Phyllosilicates means a sheet structure arrangement wherein they will have one silica tetrahedra sheet and one aluminum octahedra sheet. So followed by one more silica tetrahedra sheet. So that means aluminum octahedra sheet sandwiched between two silica tetrahedra sheets in case of phyllosilicates. Whereas in other primary minerals, so what I just listed, so all of them will have a silica tetrahedra sheets only in the form of chain or discrete units or in pairs, so or in form of cycle, so or three-dimensional framework, except phyllosilicate. So that means the correct answer is all primary silicate minerals excepting phyllosilicates have silica tetrahedra. That is the answer. That is what you have to think always. Aluminum octahedra is there in case of primary minerals only in the micas, the phyllosilicates. While in case of clay minerals, both silica tetrahedra and aluminum octahedra will be there. Like you can take montmorillite, you can take vermiculite, you take kaolinite, you can take illite, you can take chlorite. All of them will have silica tetrahedra as well as aluminum octahedra sheet. So based on the arrangement, we classify them 1:1 clay or 2:1 clay or 2:2 clay, right? So that is how the clay mineral will be grouped. Okay, which of the following is not true of a single silica tetrahedron? So you just read this. The atoms of the tetrahedron are strongly bonded together. What are the atoms we have in silica tetrahedra? We have silica and oxygen. Okay, it has net negative charge. So because if there are 4 oxygen and 1 silica, silica is tetravalent, carries 4 positive charges. Oxygen, each oxygen carries 2 negative charges. So that becomes 8 minus 8 plus 4 minus 4. Always will have negative charge. It has 4 silicon atoms. So
C.
no, it's not the case. But I have taken this question, framed this question specifically to tell you there is a wrong statement in this multiple choices. The last one also you can see all of these are true of a single silica tetrahedron. When the third one is not correct, how can it be? So it's not suiting, right? This is where sometimes there will be confusion actually. It has 4 silicon atoms. So all of these are true of a single silica tetrahedron. So cannot be an answer, right? So there are these 2 has to be changed. So if you get this kind of things, you just keep it out and you can take this as a challenge also later on. Okay, which of the following minerals will weather most rapidly at Earth's surface? Olivine, quartz, so anorthite, biotite.
Olivine.
Olivine. Why?
Sir, sir,
Yeah.
it is most weathered minerals. It
No,
is known
but
as West. Sir,
okay.
it is, sir, it comes under orthosilicate. That's why.
No, need not be like zircon is orthosilicate. I given an illustration of identifying zircon to identify the age of the planet, the rock system, the other day.
Yes, sir.
Yeah. Then, okay, you are right. So I'll tell you why now. Olivine, quartz, anarthite, biotite. So olivine is a ferromagnesian mineral with independent silica tetrahedra. Okay, the quartz is a tectosilicates. So then anarthite is a calcium plagioclase. Biotite mica is a ferromagnesian minerals. Okay, now consider where they have formed, at what temperature they have formed. In the magma, the first mineral to be formed is olivine, right? So it is when it exposed to ambient conditions, that is temperature, air temperature, and the earth surface conditions, it feels like you and me homesickness. It is away from the home. So that's why it will be more susceptible to weathering. And so also iron is there. Just imagine if iron in biotite or olivine is there, if it get oxidized, what is the form that it can form iron? Fe2 plus is oxidized to Fe3 plus. Okay, when Fe3 plus is formed, definitely one of the cation having monovalent charge has to leave the structure. Then only the structure will be stable and neutral, because one positive charge has been increased due to the oxidation of Fe2 plus to Fe3 plus. So this is the oxidation reduction weathering process happens. So that makes the ferromagnesian minerals more susceptible to weathering. More susceptible to weathering. Clear? Someone has answered me that's olivine.
Yes, sir.
Are you convinced?
Yes, sir.
Okay. So Ritik Kumar, right?
Yes, sir.
Okay, that's fine. Fantastic. Okay. Just move on to that structure. Just look at this. So probably it is not visible properly because I'm not putting it on slideshow. So that's why just somehow I'll try to adjust these things. Yes, SiO4, 4 minus tetrahedron. Each silica atom is covalently bonded to 4 oxygen atoms. Okay, that is the basic thing. So in the tetrahedron, silicon has an oxidation state of +4. Remember oxidation state. It has got +4, that is tetravalent. And oxygen has an oxidation status of -2. Overall charge on the tetrahedron is +4 plus 4, 4, right? 4 into 1, so that becomes 4 only, and 4 into -2 becomes -8, so -4 negative charges. The SiO4 tetrahedron can be represented in different ways. So ball and stick model, triangular, and all those things. So now coming to the next point, the tetrahedra can link together by sharing corners, resulting in SiO-Si covalent bond. So remember here one thing, there will be 4 oxygen and 1 silica. The oxygens are so arranged in a triangle position, 3 oxygen atoms, so that each touching other 2. The 4th one sits on top of this triangular arranged oxygen atoms. So now it touches all the other 3 oxygen atoms. The central space is created, can fit actually the silicon atom. The ionic radii of silica is around 0.42 angstrom exactly. Suppose if the smaller ionic size cation enters inside, so the structure cannot be stable. And if the bigger the ionic radii element like potassium enters, so then the structure once again it will not become stable, because it pushes away the oxygen. If it is small, then oxygen gets repulsed each other. So that is what happens in that. So okay, we'll move on to the next one. So here in order to reduce the negative charges, in the nature, it's reconciled or reduced by sharing oxygen atoms with neighboring silica tetrahedra, or get attracted to the oppositely charged cation. So that is what happens in case of olivine. Olivine, you remember, one single tetrahedra will be there with 4 negative charges. To satisfy those 4 negative charges, the Fe2 plus and Mg2 plus will get attached to it, so that it becomes neutral. So a stable mineral compound. Okay, so now we can see this here. So discrete molecules wherein only one oxygen is shared, so that is pair. Okay, so here you can see the discrete units wherein 3 silica tetrahedra each sharing 2 of its oxygen with neighboring silica tetrahedra. If you consider any one of the silica tetrahedra, you can find one here, you can find one as shared oxygen. In case of infinite single chain structure, you can see here once again 2 oxygens are shared with neighboring silica tetrahedra. And in case of double chain bands, you can see in the vertices, so the 3 oxygens are shared. If you can see here 1, 2, 3, but outside it's only 1 and 2. So that's the 2 kinds of tetrahedra we have in case of the double chain silicates. Okay, so this is the infinite double chain and infinite sheets. So in case of sheets, so silica tetrahedra sheets, so and 1 aluminum octahedra sheets will be there. And the 4th one is the framework silicate. So that is the 3-dimensional framework wherein all 4 oxygens are shared with neighboring silica tetrahedra. So now you can see this, the structural formula, molecular formula, that is discrete unit formula. So single tetrahedron, so the formula is Si4, 4 minus. In case of 2 tetrahedra sharing a corner, that is paired sorosilicates, it is Si2O7, 6 minus. So in case of 3 tetrahedra in a ring, so 3 tetrahedra, it can be 6 tetrahedra at the bottom. So the formula, unit formula is S3O9, 6 minus. So in case of 6 tetrahedra, then it becomes S6O18, 12 minus, that is the charge. So then in case of, so you can see infinite single chain, the formula for, you can see the red box for repeating unit shown in red box. So SiO3, you can see here, 1 is on top and 1 is on bottom, and this one is at the side. These 3 oxygens are shared. So similarly, when it comes to infinite double chain, Si4O11, 6 minus, you can see here all of them. So this is 1, 2, 3, 4, 5, 6. And so that entire unit will be there. And similarly, if you can count them, there will be exactly the same number. Infinite sheets, yes, Si2O5. For 2 Si, so we'll have 5 oxygens in this. So per silica, it will be 2.5. It will be 2.5. So now we'll just see this table. Yes, you can see this table. Now you can see this. So silicates, primary silicates especially, based on the arrangement of silica tetrahedra, has grouped into 2 categories. One is simple silicates and the second category is complex silicates. Simple silicates, we don't have further subdivisions. It is only nesosilicates, orthosilicates or island silicates. So those are the words commonly we come across in the examinations. So then in case of complex silicates, we have sorosilicates, cyclosilicates, inosilicates, maybe single chain or double chain, phyllosilicates, sheet. So tectosilicates, three-dimensional framework. So that is the tetrahedral grouping. Silica oxygen ratio in each of these groups, in case of nesosilicates, which is otherwise called as orthosilicates or island silicate group. So 1:4. In case of sorosilicates paired, it's 2:7. Cyclosilicate 1:3. And case of inosilicates, once again 1:3. Phyllosilicates 2:5. And tectosilicates is 1:2. Net negative charges per silica. So -4, because all the 4 oxygen in case of independent silica tetrahedra are unshared. So definitely it will have 4 negative charges. And in case of the sorosilicates, it will have the -3, -2, -2, -1.5, -1, and 0. Examples are the nesosilicates olivine. So in case of sorosilicates hemimorphite, so cyclosilicate beryl, a gem variety. So in case of single chain, it is agate. So double chain, it is hornblende. So sheet, mica. So three-dimensional framework, quartz. So this is the information that I wish to pass on to you. Now we'll come to it. Which is not matched correctly? Yes, quickly.
Potassium feldspar.
Yes, potassium feldspar. So it is not isolated silica tetrahedra. It is tectosilicate. Tectosilicates. Others are correctly matched. Okay. Which of the following is not an orthosilicate? Zircon, olivine, beryl, all of this.
Beryl.
Beryl, because it is belongs to cyclosilicates. Correct? You can see here, nesosilicate, cyclosilicate. Orthosilicate is also referred as nesosilicate, simple silicate, and island silicate. Island silicate. So amphibole silicate minerals consist of single silicon tetrahedra, chains of silica tetrahedra, double chains of silica tetrahedra, sheets of silica tetrahedra.
B.
C.
B.
So C.
C, yes, C is right. C is right. So because it's a double chain of silica tetrahedra, where 2 single chain cross-link each other. So that is the double chain silica tetrahedra. Feldspar are oxides and hydroxides, framework silicates, double chain silicates, carbonates.
So
Framework
B.
silicate.
B,
B.
yes. Very good, fantastic. So I think you all had a working lunch only. Okay, one more question with feldspar. Feldspar are oxides and hydroxide, similar to quartz, but with isomorphous substitution of silica with aluminum, double chain silicates, carbonates. I have added another choice, another dimension to the same question. I just removed that B there and I added here similar to quartz. Quartz also is a framework silicate or tectosilicates, wherein, so in the out of 4 units of silica tetrahedra, in one of the unit, silica is replaced by aluminum. So as a result, so one negative charge will be created. So that negative charge is neutralized by potassium. So that's how the feldspar is created. KAlSi3O8 is the formula for feldspar. I'll repeat. KAlSi3O8 is the
Yes, sir.
formula for the feldspar. It is sodium plagioclase or albite. It is NaAl, right? Si3O8. Okay, in case of anarthite, the formula is the calcium Al2 Si2, so O8. That is the formula. That is how it is. Substitution happens in case of the tectosilicates. Tectosilicates. Clear? Do you have any doubt? Please. Hello.
No, sir. No, sir.
Okay. So then coming to the Fe in sesquioxides is dominant in the form of, it will have iron in the form of what? And remember here, sesquioxide, there is no chemical name as such. It represents iron and aluminum oxide, right? So that is the basic thing you have to remember. So in which of the form iron will be present in sesquioxide?
Fe2 plus.
Fe2 plus. Okay. Anyone can bet on any other choice? Your betting money will be 1:5. If you bet on 1 rupee, you will get 5 rupees. Ritik, yes, he wanted to
sir.
bet 10 rupees on one option. Which one?
Sir, Fe2 plus.
Fe2 plus. Okay.
Yes.
Oh, what is the formula for iron and aluminum oxide? Fe2O3?
Yes, sir.
Now, can you tell me where that 2 has come from? Oxygen, right? 3 has come from iron. So remember your chemistry.
Fe3 plus then, sir.
Yeah, Fe3 plus.
Yes.
So
sir.
it is Fe3 plus. See, this is a simple question, right? So we have to think of it. Remember quickly the formula for the iron aluminum oxide, Al2O3, Fe2O3, something like that, right? Okay. Which of the following is the most resistant in soil? Quartz, feldspar, mica, gypsum.
Sir, quartz.
Quartz, yes. So you have won 101 rupees now betting on quartz. Yes, that is fantastic. Quartz is fine. So why not feldspar? Not feldspar. Here is the most resistant. Feldspar is susceptible to weathering compared to that of quartz. Why? I did mention a few slides back what happens to quartz, how the feldspar forms.
Sir, isomorphous substitution.
Yeah,
Okay.
there is a substitution. So that makes the structure weak. So that's why it is the susceptible, less resistant as compared to that of quartz. And mica is a ferromagnesian mineral, right? So yes, iron can be subjected to oxidation and reduction. So oxidation and reduction, weathering takes place in minerals having iron, manganese, and sulfur. Okay. So similarly, mica, gypsum. So it is a calcium sulfate, 2H2O. And suppose if somebody asks which of the following is most susceptible in tropical condition?
Gypsum.
Yes, gypsum. So suppose the same question, which of the following is most resistant in arid climate? Yeah, gypsum will be there because the saline soils you'll find in arid soils, arid condition, right? So gypsum and calcium carbonate will be there even in arid and semi-arid climate condition. So because the climate is not so harsh, so they will try to keep them. So that is the reason. So as you move towards coastal regions, so you will not find the calcium carbonate, even if you dig a soil up to 3 meters or so, or 4 meters, maybe it's still at the bottom, you may have the calcium carbonate. Otherwise, so in arid climatic conditions, we will have gypsum or calcium carbonate at the top itself. Which of the following is not a primary mineral?
Kaolinite.
Kaolinite. Okay. Why? Kaolinite has been formed from feldspar, right?
Yes, mica
Yeah.
is
Mica maybe might have given the kaolinite. Yes, because quartz, feldspar, mica have been formed from magma directly, whereas kaolinite has been formed from weathering of feldspar under tropical conditions. Okay. The general formula of cyclic silicate is cyclic silicates is the units can be for cyclic units 3 or 6. And 3 and 6 are not there in any of the choices. Right? If you see SiO4, that is independent silica tetrahedra. S2O5, so it is more than 1, it is not 3. S2O7, and similarly SiO3, if N represents 3 or 6, then it becomes cyclosilicates. Do you agree with me? Or 1? So suppose if it is 3, then it becomes 9, then Si3O9. If it is 6, it becomes Si6O9. 6 times 2 becomes minus 12. So that is the formula that I have given you earlier. You can just see this here. Orthosilicate, sheet silicate, sorosilicate. So then the answer D is correct. N is 3 or 6. N is 3 or 6. Which statement about silicate is not correct? Silicon is 4 coordinated to oxygen atoms. Remember, silica and oxygen bonding is covalent bonding, strong bonding. So there are 3 kinds of bonding, right? One is ionic bond, covalent bond, and metallic bond. So now covalent bond in case of silica and oxygen, right? So then asbestos is an amphibole silicate. Yes, it is true. Talc and mica are examples of chain silicates. Yes.
Sheet
Zeolites
silicate.
are aluminosilicates. Aluminium is not given in any other silicate minerals. So that means it is zeolite is the answer for this question. Correct. So 1 minute, I'll just take a break. So some students have come with some issues. So microporous aluminosilicate minerals commonly used as a commercial adsorbent and catalyst. So that is the zeolite uses. Please do come. So I'm sorry for the interruption. Okay, which of the following statement is correct for amphibole silicates? So amphiboles, double chain silicates. Remember that. Right? It's a ferromagnesian mineral. The example for amphibole silicate is hornblende. Very, very important soil forming mineral. So they are dark colored minerals. So now you have seen this, the empirical formula is SiO3 2 minus N, right? So for something else in the previous question, sharing of only 2 oxygen, yes, this is only outside, but what is this? It shares 3 oxygens inside. I've shown that in the diagram. There is independent tetrahedra, no way, no chance, because so it is a chain, double chain, 2 single chain cross-linking each other. So then the empirical formula is Si4O11,6N. That could be the formula. So the options that I'm selecting here based on elimination, because I know that. So there is independent tetrahedra is not there. It is shared tetrahedra. So the option C is eliminated. Sharing of only 2 oxygen, yes. Outer side it will be 2, inside it will be 3 oxygens are shared. So I know that basically by looking at the diagram. The empirical formula is SiO3 2 minus, it's a cyclosilicate. I know that. So that's how I eliminated and came to conclusion that the 4th one is correct answer. The empirical formula is this one is correct. Okay. The silicates in which the 3 oxygen atoms at the vertices of tetrahedra are shared. The silicates, in which of the silicates? And I'm telling you, amphiboles, the name is a group name. The dark colored mafic minerals, mafic felsic minerals. There are 2 words. Felsic means felspathoid silica, that is feldspar and silica. So mafic, magnesium and iron containing. Mafic minerals are denser, so while felsic minerals are lightweight. So they are light in color, mafic minerals are dark in color. So amphiboles, pyroxene, once again the example for pyroxene is agate. Nesosilicates, independent silica tetrahedra, olivine. Pyrosilicates, paired silica tetrahedra, hemimorphite. So the silicates in which the 3 oxygen atoms at the vertices of tetrahedra are shared. So in case of the pyroxenes, only 2 oxygens are shared because it's a single chain. In case of amphiboles, 3 oxygens are shared. So that is how we have to take this answer. Isosilicate, there is no sharing. In case of pyrosilicates, is only one, the apex, the oxygen is shared among the 2 silica tetrahedra. Okay, in which of the following silicates there are 2 types of silica tetrahedra, those sharing 3 vertices and those sharing 2. See, for the same mineral group, right? So you can see the framing of questions can be based on concept, right? So based on logic. So that is what you have to visualize actually. So there will be some questions based on concept. So there will be simply some questions, direct questions. Concept-based questions definitely requires a thorough understanding of the topic. Then only you will be able to answer the concept-based the questions. So now I have indicated already. So in the single tetrahedra, only 2 oxygen are shared. So if you just consider, there will be like one is like this, and another one is like this, and the third one is like this. So here 2 oxygens are shared, whereas in this, the downward facing the silica tetrahedra, it is not sharing. When the another chain comes and cross-linking happens, this oxygen is also shared. So in that way, so all this is true for amphiboles. So that's why the answer is C. The ratio of silica to oxygen in phyllosilicates is. Yes, please.
C.
Yes, C is correct. Ritik Kumar, yes, it is 2:5. So just here, 2:4 is tectosilicates, because when you simplify it, it becomes 1:2. Remember this, right? So 1:4 is nesosilicates, 2:5 is phyllosilicates, and 1:5. This is hypothetical ratio that has been given in this option. Okay, muscovite is a double chain silicate, a framework silicate, a sheet silicate, a single chain silicate. So this is simple, straightforward question. Mica is a phyllosilicate. So laminar or sheet-like arrangement. So that means it's a sheet silicate. What is the parent material of all soils?
Regolith.
Regolith. Yes. Any others? What is the parent material of all soils?
Rock.
Rock. Yes, you are taking bet on rock. Yes, fine. That is the basic starting material. Okay, I'll just explain a bit here. So rock is consolidated, a hard substance of one or more mineral. Is an aggregate of one or more mineral. Monomineralic rock, the example is dunite. So polymineralic rock, example may be granite or basalt, right? Monomineralic rock means a rock composed purely of single mineral, right? Maybe limestone also. So the rock containing more than one will be the polymineralic rock. It's a consolidated. So when it becomes unconsolidated as a result of weathering forces, it may be physical or chemical. And my dear heroes and heroines, please do remember there are only two kinds of weathering. But you must have been taught or you must have read in books that there are three kinds of weathering. One is physical, second one is chemical, third one is biological, right?
So biological weathering only helps in the chemical weathering.
Yeah, it can be
Biological
like
agents.
biological weathering. As such, it is not there. So it is part of physical or chemical weathering, aided by, accelerated by, helped by the biological agents. So organisms, living organisms. So that's why I always say that there are only two types of weathering, physical and chemical. So physical and chemical weathering brings about or breaks the hard mass into fragments. Once the fragments are formed, we call them as a regolith. So from regolith, when regolith is subjected to the influence of soil forming factors and soil forming processes, that is pedogenic processes, it changes into solam. A and B represents solam. A, B, C represents regolith, right?
Yes, sir.
Right. Okay. And that means weathering, the role of soil forming factors and pedogenic process are all operating simultaneously. So weathering process never tells, soil forming factors never tells the weathering agents, no, please wait, I'll complete my part, then you can start further weathering. Or weathering will not tell that, so soil forming factors, no, Baba, please wait. I have to do my job. I have to make this consolidated rocks into unconsolidated portion. Then you can start your work. So it is not happening. It is a simultaneous job. So that changes the hard rock mass into regolith. From regolith, it changes to solam. So that's why the parent material of all soil is the regolith. Okay. A color is produced due to, simple, straightforward question for you. Quickly your answer. Sorry, I'll have water.
Absorption.
Okay, you are taking bet on absorption, right, Ritik Kumar? Yes, anyone?
Yes.
So I think you are taking too long to answer a question related to color. You must have learnt a rhymes on this color, what color, right? All of you must have played with that rhyme. Yeah, please, someone. Yes, please give me some answer. Tamanna Sharma, are you hearing me?
Yes, sir.
Yeah. On which option you are taking bet?
Sir, I think option D.
Option
B.
B. Okay.
Reflection.
Reflection. Okay. Okay. Why our hair appears dark?
Due to melanin pigment.
What does it do with light?
All the colors, sir.
It absorbs all the color, right? Yes. Why the plant leaf appears green?
The absorption of
Because all other the colors are absorbed, reflecting only green light, right? So that means the option is reflection and absorption. See, simple question. So looks very, very simple. As soon as you see this color is produced due to, yes, quickly you'll take it. But you have to analyze, you have to think why the examiner has given such a simple question. Right? Okay. A color is produced due to, that's what explanation. The particular color is produced by reflection of some and absorption of other components of white light. The type of mineral showing variable color is idiochromatic, allochromatic, iridescent, so pseudochromatic.
Allochromatic.
Allochromatic. Allochroma means color, allo means many, the meaning. Idio, single, chroma means color. Pseudo means false color. Okay, I have another question. The type of mineral which shows set of colors in succession. Idiochromatic, pseudochromatic, allochromatic, iridescent. Okay, probably this is somewhat tough. You just look at this. It is called pseudochromatic minerals. Shows false color. Such an effect generally happens when a mineral is rotated in hand. It is then seen to show a set of colors in succession. You have seen with sometimes the holding a rupee coin or some shining material on your hand. So maybe pearl, something like that. You must have observed when you turn this a different color, when you turn that side, the different color. But in the scale and other things, you have seen those things, right? The changes with lines. That is because of grating. So that grating, so probably you have seen that in case of instrumentation. You must have heard that word in case of instrumentation. Okay. Type of shine or luster associated with diamond is
Vistas, sir.
Hmm?
Vitreous.
The type of shine or
Clearly.
luster. Yeah. Which one? Sri Likita? So probably all of you have seen some movies where the villain is holding some diamonds. As soon as he is holding in diamonds on his hand, so they'll put a star lights like thing to show that it is exceedingly brilliant. So that adamantine luster is the answer for this. So adamantine luster, that is the answer for this question. Now, the scale of hardness is given by
Mohr scale.
Mohs scale. Yes.
Yes, sir.
So Richter scale is for
Seismic waves, sir. Seismic.
so measuring vibrations, right? Seismic scale. Ohm, so measuring current strength.
Yes, sir.
Yeah. So that's what you have to remember quickly. Yes, you are right. And here comes the Friedrich Mohs proposed a relative broadly quantitative scale of hardness of minerals, assigning values between 1 and 10. The softest mineral is talc. The hardest mineral is diamond. If you just look at this here, hardness 3 is assigned to calcite and 4 is assigned to fluorite, 5 is assigned to apatite and 6th is assigned to orthoclase, 7th is quartz, 8th is topaz, 9th is corundum, 10th is diamond. Remember here, I'll just give you one clue here. So gypsum cannot make a scratch of calcite, while vice versa is true. Calcite can cause a scratch on gypsum. All are arranged like that. So suppose if take the topaz, so it cannot leave a scratch mark on corundum, while the corundum can give a scorch mark so on topaz. So that is how it's arranged. And fingernail, kitchen knife, window glass, steel file are used to assess the hardness in the field. Okay, so this is where I was talking about plate tectonic. If you can see this, the subduction, so that means convergent plates. So coming together and one going downwards here. So so it leads to the rise of the continent. And this can be the ocean lithosphere, and this is continental lithosphere. So both of them have come and collided. As a result, this has come down and one has risen to make a mountain things. So the surface is rising like that. Okay, with this, I'll just move on to tell you something about the rock cycle diagram.
ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀರಾ ಸರ್? ಓಕೆ ಓಕೆ ಕ್ಯಾರಿಯರ್. ಆ ಬ್ಯಾಚ್ ಮುಗಿದಿದೆ, ಮೇಡಮ್ ಹೋಗ್ತಾರೆ. ಜಸ್ಟ್ ಸೇ ಒಂದು
Okay. Okay. Sorry, my dear students, because there was a guest from Hyderabad managed. So I was talking to that lady. So the concept of rock cycle is attributed to James Hutton. So 1726. So now I'll just explain what is that, the James Hutton's rock cycle. So we'll start with the magma. So this is where the magma. So cooling and consolidation results in the formation of igneous rocks, right? So when igneous rocks are subjected to weathering, so they lead to the formation of sediments. Consolidation, compaction and consolidation, cementation, diagenesis, all the process leads to formation of sedimentary rocks. So when the sedimentary rocks are subjected to pressure and temperature, so they'll change it to metamorphic rock. Further increase in the pressure and temperature leads to the formation of magma. So this is a simple cycle, but the nature do not allow this to happen so easily. There have been so interferences in the middle. So for example, if you take igneous rocks, so then this igneous rocks may change to metamorphic rock if magma intrusion is there, or if there is a change in heat and the temperature. And similarly, the metamorphic rocks can become sedimentary rocks. If the heat and pressure to change them or melt them is not sufficient, then they will form sediments, and these sediments undergo the process of sedimentation, resulting in the formation of sedimentary rocks. So this is about the rock cycle, and I have given examples of that. So this is the magma, and we have in another one. So igneous rocks, rock formed from the cooling and hardening of magma, basalt, granite, obsidian. So very glassy texture here, fine texture obsidian. And remember one, the pumice is there, it floats on water because the density is around, the specific gravity is around 0.92 or 95, I don't remember exactly. So lower than specific gravity of water, so that's why it floats. So pumice, smoothing of this skin and other things.
Hello, sir.
Yeah.
Hello, sir. Sir, my question is there is the
Hello.
myth of the floating of the rock of Ram Setu.
Yeah.
Hello, sir. Am I audible to you, sir?
Yeah,
Yes, sir.
please.
Suman, sir. My question to you, sir. There is the myth to floating of rock of Rama Setu. So it is a pumice or on any other rock? You have any idea about this?
Surender,
Sir, rock of Ram Setu is floating on the
rock of,
It's a pumice or a spongy type of
yes,
Ram
spongy
Setu,
rock.
Ram Setu, sir. It is Sri Lanka, sir. Ram Setu.
Yeah.
Yes, it's a spongy rock.
Okay.
That's why it is floating.
Okay. So this is a sediment, and these are the sediment rocks, conglomerate, limestone, and sandstone. And these are metamorphic rocks, gneiss, marble, and quartzite. And if you just look at this igneous rocks, the term igneous is derived from Latin word ignis, means fire. So igneous rocks are formed by the cooling of molten magma or lava near, just see, comma, at or below the earth's surface. So it can form anywhere. So it can be of the earth's surface or the below the earth's surface. So igneous formed from magma and lava. Magma is molten rock below the earth's surface. Lava is magma on the earth's surface. Pyroclastic material, pyro means fire, clastic means debris. Airborne lava cools as it falls. So that is the thing. I'll just show you that what it is like. If you just look at this, so this is the pyroclastic material. As they falls into the water, so they'll get cool, and there can be air packet inside. So as a result, they can float. So if the air packets is retained, if the air packets so is not there, then there could be a synthesis. So that results in the amygdaloidal basalt kind of rocks. So these are the rocks that are formed from pyroclastic material. So if you just look at this categories of igneous rocks, intrusive rocks cool beneath Earth's surface. So that is igneous rocks are so based on the origin, they are classified as intrusive rocks, extrusive rocks, and complex. Cool beneath the Earth's surface. cool very slowly, higher pressure and temperature. So pheneritic texture, that is coarse texture. Extrusive rocks cool on earth surface. So cool relatively fast, lower temperature and pressure. So aphanitic texture or pyroclastic texture. Both textures we can have here. Aphanitic means fine texture. Complex, so partially cools below and above. So porphyritic texture, you can see here basalt porphyry. So some crystals have taken longer time for cooling. As a result, you can see those minerals and the matrix material. So they have cooled very quickly. So that's why they are fine in texture. And if you can see the other words, batholith. So we can see this batholith. So large mass of cooled magma. So this is the batholith. So then stock, smaller areas of cooled magma. So this is the stock, smaller area of the cooled magma. This is the stock. Laccolith spreads horizontally, lake of rock. So like a mushroom, pushing the lithosphere hard rocks upward. Then sill runs between the rock layers. So these are the sill. So then dike, fill vertical fractures. So fill vertical fractures, this one. So then volcanic neck, so inside the volcano. So these are the other terms that will come across in multiple choice questions, and probably the batholith and laccolith they have asked already number of times, and of course dike too. So these are the examples, are the meaning of these words: batholith, stock, laccolith, sill, dike, and volcanic necks. So coming to the sedimentary rock, sedimentum, Latin word to settle. So sedimentary rocks are formed by the lithification of inorganic and organic sediments deposited near or at the earth surface. So they are the sedimentary rocks. And you can see the examples are the other names of the sedimentary rocks. They are called stratified rocks. They are called aqueous rocks because water is the main agent in the formation of sedimentary rocks. So shale is the most dominant in the upper part of the earth crust. So sandstone, so limestones are the important rocks in the sedimentary rock system. Bedding or stratification is common in these rocks, sedimentary rocks, and even gradations also. So sedimentary rocks, they may be clastic, formed from fragments of other rocks. They are called the detrital or fragmentary rocks. Chemical, formed from mineral grains that come out of solution. Organic, formed from the remains of plants and animals, may be coal. Example, if you just look at this clastic rocks made of fragmentary material deposited by water, most common wind, glacial action, gravity. So biochemical sedimentary rocks are evaporation rocks formed. The example is the halite. So precipitation is calcium carbonate. So then biogenic sediments are called the coral and other things. So evaporation is even the calcium sulfate also evaporation. Gypsum. So coming to the metamorphic rock. So meta means changes, Greek word. Morph means form, Greek. A rock that has been changed from its original form, parent, by heat, pressure, and fluid activity into a new rock, that is daughter rock. So that is the metamorphic rock. So metamorphic rocks are formed when pre-existing rocks are transformed into new rocks by heat and pressure, usually below the earth's surface. So this is another important question that is asked in the year, I think, 2016-17, low-grade metamorphism and high-grade metamorphism. Low-grade metamorphism takes place at temperature between about 200 to 320 degrees Celsius. So, and high-grade metamorphism, so takes place at temperature greater than 320 degrees Celsius. So that is the difference between the low-grade and high-grade metamorphic rocks. A rock that shows no foliation is called a hornfels if the grain size is small, and a granulite if the grain size is large. So that is the difference between hornfels and granulite. So these are some classification rocks: sedimentary rocks, clastic, chemical, biological. So igneous rocks, intrusive, extrusive, metamorphic, foliated and non-foliated. So with examples for each of these classes. Clastic conglomerate, breccia, sandstone, siltstone, mudstone, shale, chemical limestone, dolostone, dolomite, then evaporites, biological, coral, chert, etc. Intrusive rocks, gabbro, diorite, so granodiorite, granite. So extrusive basalt, andesite, dacite, rhyolite are the examples. Metamorphic rocks, foliated, the slate, schist, gneiss, and non-foliated quartz and marble. Which is not an intrusive rock type? Gabbro, diorite, granite, and andesite. You can see here, gabbro is a dense mafic intrusive rock. Diorite is an intrusive igneous rock. Granite is an intrusive rock. So andesite is an extrusive rock. So the question is, which is not an intrusive rock? Andesite is the answer for that. Rock is collection of one or more minerals, can be solid organic matter, can be non-crystalline, all of these.
A.
Collection of one or more minerals.
Yes, sir.
So coal is there. So it can be non-crystalline also, like obsidian.
Sir, but can be solid organic matter? How?
Yeah, solid organic matter means the growing along with plants or burying of plants leading to the formation of sedimentary rock called coal. Biogenic process.
Along with organic substances.
Organic substances. So that means they'll be partially decomposed. Then they are partially decomposed. We call them as organic matter, right?
Okay, sir.
Depending upon the degree of carbonization, 72 or anarthite, something like that. More than 92% carbon is the bituminous coal or anthracite coal, maybe. So there I'm just confusion. Please read that, right? Based on carbon content of the materials.
Anorthite, sir. Anorthite.
Okay, collection of one or more mineral, granite, can be solid organic matter, coal, can be non-crystalline, obsidian. Hence the answer is all of this. Which of the following is an igneous rock? Quartz, marble, mica schist, obsidian. Obsidian is the correct answer, right? Quartz is a mineral. Marble is a metamorphic rock. Mica schist is also metamorphic rock. Obsidian is a igneous rock. What is the state of lava or magma? Liquid always, solid always, gaseous always, mixture of liquid, crystals and gases. So I have shown you pyroclastic. Pyroclastic means some crystals coming out.
D.
Right?
Answer is D.
D is the correct answer. Yes. So this is the explanation. And then stratification can be seen widely in which of the following rocks? Stratified rocks.
Sedimentary rock.
Sedimentary rocks.
Yes, sir. Sedimentary rock.
Sedimentary rocks.
Sir, and what is foliated rock?
Foliated means like a sheet-like arrangements. The foliated rocks, it happens if the pressure is uniform from one side. Are you getting my point? Like, for example, if you have something soft material, put your palm on that. So if you press it, it gets flattened. So even if the crystals are longitudinally arranged in the earlier material, so they get flattened like this. So that is the foliations. Foliage, leaves like, Greek word. Most widespread rock on earth. Which one?
Igneous.
Igneous rock.
Igneous rocks, 95%. Yes, definitely. It is said that sedimentary rocks are superficial. So the most widespread rocks forming more than 75% of the exposed surface of the earth. So the most widespread rock on earth, on the surface, it means. But the correct answer for this is igneous rock only.
Yes, sir.
Yes.
B is for only 5 kilometers of the.
Yes. 16 kilometers.
16 kilometers.
Yeah. See here, most widespread rock in the entire crust within the earth. See, the same question I just formulated differently now. Here it is very clear. In the entire earth crust is igneous rock, right? 95% of the rocks are igneous rocks in the earth crust, up to 56 kilometers. Foliation is a primary structure of which type of rock?
Metamorphic rock.
Metamorphic rocks. So that's what I said. If the foliation occurs, foliage means leaves like. So that happens only if the pressure is uniform from only one side. If it is from all these sides, right? So then it cannot be foliations. Sandstone and limestone are the examples of sedimentary rocks.
rock.
Sedimentary rocks.
Sedimentary rock.
An average silica content of igneous rocks. Answer is A, 40 to 70%. My explanation for that comes here. In a widely accepted, right, silica content classification scheme, rocks with more than 65% silica are called felsic, so light in color, felspathoid and silica. So those with between 55 and 65% silica are intermediate. Those with between 45 and 55% silica are mafic. Those with less than 45% are ultramafic. That is also related to acidic, basic, neutral, and ultra basic rocks. Correct?
Yes, sir.
Compilation of many rocks analysis show that rhyolite and granite are felsic with an average silica content of about 72%. Cyanite, diorite, and manganite are intermediate with an average silica content of 59%. Gabbro and basalt are mafic with an average silica content of 48%. Peridotite is an ultramafic rock with an average of 41% silica. So now I have given you complete classification of rocks with respect to silica content. Felsic igneous rocks containing a high silica content greater than 63% SiO2. Examples granite and rhyolite. So intermediate igneous rocks containing between 52 to 63%. Example andesite and dacite. Mafic igneous rocks have low silica 45 to 52% and typically high iron magnesium content. Example gabbro and basalt. So based on chemical composition, that is SiO2 content, oversaturated igneous rocks are those which are having SiO2 content greater than 65%. Example, granite and rhyolite. Same names with different, same examples for different the questions like saturated neutral rocks, SiO2 content is in the range of 65 to 52. Unsaturated basic rocks, so SiO2 content is 52 to 45. Ultra basic rock, SiO2 content is less than 45. Dunite and peridotite are the examples for this. Because in this, number of questions may appear. This looks very, very small table having about 5 bullet points, but you can draw number of questions from this. Like for example, a acidic intrusive rock, acidic extrusive rock. Example, in intrusive acidic rock is granite, extrusive acidic rock is rhyolite. So fine texture rock among them is a rhyolite. So granite has a coarse texture. So that's how many questions can be framed out of this simple the bullet points slide. Olivine is the most dominant mineral in which of the following igneous rocks? It is peridotite. Almost 95% of peridotite is composed of olivine. Fine textured acidic igneous rocks saturated with silica. So fine textured acidic igneous rocks saturated with silica, so that is the rhyolite. So highly, more than 62% fine textured igneous rocks it contains. Then, which of the following intrusive igneous rocks is also known as salt and pepper rock? So it is a diorite, is called as a salt and pepper rock. So, okay, now next question is, rock is a natural, a solid aggregate of one or more minerals, mineraloids, either A or B only, both A and B. Rock is a natural, a solid aggregate of one or more minerals, mineraloids, either A or B only, both A and B. You have to select one of them only. So for explanation, a mineraloid is a mineral-like substance that does not demonstrate crystallinity. Mineraloids possesses chemical composition that vary beyond the generally accepted ranges for specific minerals. For example, obsidian is an amorphous glass and not a crystal. So that being the explanation, what is your
Either A or B.
Either A or B? Yes, correct. So there is, here I have just given the mineraloids example, some more examples. Okay. Graded bending occurs due to which phenomenon? Wind settling, sunlight, gravitational settling, loading. It's a gravitational settling, graded bedding happens. Suppose if the sediment is loaded in water, like for example, sand, silt and clay, take an example, recollect your mechanical analysis. Suppose if you allow the particles to settle, which one settles to the bottom?
So sand.
Sand. Next,
Silt.
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 Next, clay.
Clay.
Yeah, that is the gradation as a result of gravitational influence. Okay. Mud cracks are common in which type of sedimentary rocks? Fine grained, medium grained, coarse grained, not particular. So in case of mud, the mud cracks we'll see only in case of clay, not in coarse grained. Coarse grained means the particles are bigger in size. So you can see here This is the mud cracks. In case of sedimentary rock, this is sedimentary rocks. So fine grain only. The major difference between breccia and conglomerate is grain size, grain rounding, grain rounding is there. I have given the answer. I'll just show you the picture. You can see this. This is breccia. The mineral fragments, the rock fragments, which are lithified or consolidated into sedimentary rocks, are still irregular. Whereas here, the fragments are rounded, somewhat smoothened in case of conglomerate. So that is the difference between conglomerate and breccia. Both of them are detrital rock, fragmentary rocks, sedimentary rocks. Shale differs from mudstone in that, so shale is a layered and fizzle, whereas mudstone is massive. That is the only the difference between shale and mudstone. Mudstone and shale are made up of silt and clay-sized particles. Mudstone and shale is that mudstones break into blocky pieces, whereas shales breaks into thin chips with roughly parallel tops and bottoms. Both are made of ancient mud. The rock is coarse-grained in volcanic rocks, plutonic rocks, hypabyssal rocks, always not found in igneous rocks.
Volcanic rock.
Plutonic rock.
Coarse-grained. Volcanic rocks, see, they are exposed to the outside very quickly and their cooling will be very fast. Can you expect the coarse grain in volcanic rocks? So if there is a sufficient time for cooling, there can be growth of crystals. So that is growth of minerals can be seen. So that is the rock is coarse grained in case of plutonic rocks. The degree of crystallization where the constituents are very fine or glassy or the degree of crystallization where the constituents are very fine or glassy or hollow crystalline, holoalline, so homoalline, homocrystalline. Answer is B. So what is the term used when constituents are crystallized completely? Answer is A, holocrystalline. Let me explain that in the next slide probably. Okay. Holocrystalline, completely crystalline, made up wholly of crystals or crystalline particles as granite. Holohyaline, so geology term, completely glassy. Obsidian is holohyaline rock. Homohyaline, just coined term, no term as such. I have searched the whole dictionary, you don't find this word. Homocrystalline, no such term also, homocrystalline. A crystalline or glassy rock formed when magma or lava cools down and solidifies is called. Whatever it is, the rocks that are formed from cooling and consolidation of magma are igneous rocks. Okay. Obsidian is rich in silica, iron, cobalt, cadmium, the calcium. It is silica only. A glassy volcanic rock formed from lava, froth which is used to smooth skin is, so it is the pumice.
Pumice.
Pumice, right?
Yes.
Iron-rich igneous rocks are denser than the rocks which are rich in silica-containing igneous rocks. Silica-containing igneous rocks. The texture which the characteristics in between granite and felsite is orthopyric. Orthopyric texture is another type of the equigranular texture, which is in between the granite and the felsite texture. The individual grains are fine in size, but not microgranular, equigranular in size. What is the texture called when the large size crystals are embedded in the fine grained matrix? The answer is C, porphyritic texture. Porphyritic texture is characterized by the presence of a few conspicuously large sized crystal, the phenocryst, which are embedded in a fine grained ground mass of our matrix. So all of you have eaten the cookies, cashew cookies or cashew good day biscuits. So the cashew fragments, so that represents the fragments. The other, the wheat flour represent the matrix. So that is what it means to say porphyritic. Porphyritic. The igneous rocks with very low specific gravity is. So here comes pumice, has a low specific gravity, whereas all other igneous rocks have medium specific gravity. This property makes the igneous rocks pumice very light. The main reason behind this is a pumice has many pores. So among these, granite, gabbro, and basalt. So regional metamorphism occurs under Earth's. Where does the regional metamorphism occurs? Core, mantle, atmosphere, crust. All rocks, solidified rocks, will find in crust. So that is where the rocks can be formed. When rocks are metamorphized, the mineral components of rock are transformed in the solid state, melted first, then crystallized again to form a new rock, shattered by mechanical process, ugly first, then beautiful. Yes, please.
C maybe.
It is actually transformed in the solid state only. The new minerals, metamorphic minerals, are formed by solid state substitution. Solid state substitution.
Sir, explain please these questions.
No, transformed in the solid state. Like transformed in the solid state is a mineral getting baked in a magma solution when there is an intrusion, when there is a contact, right? So if some other elements enters into that, replacing the earlier element, then it is a solid substitution. In case of metamorphic rock. Okay, Ritik.
Okay, sir.
Okay, there are 4 pairs of rock types below, with the left hand rock being a potential parent and the right hand being a metamorphic rock derived from that parent. Which of these is not a valid pair?
Sir, option D.
Option
D.
B.
Sir, B नहीं D.
B for Bangalore or Bombay?
Sir, D. Conglomerate.
Sir,
Okay,
D, sir.
conglomerate and phyllite. Yes, that's right.
Yes.
Shale, phyllite, slate comes here. That. Yes, you are right. Igneous rocks can be further divided based on their way of formation. That's what I told you already, that one. A dissolved minerals crystallizes to form dissolved minerals. It may be calcium, right? So it may be sodium. So it leads to formation of chemical sedimentary rock. If metamorphism continues, schist turns into rock with distinct bands known as, it is actually garnet. Schist, garnet is a mineral. Schist, so because schist is going to change, and slate, so from schist it is gneiss actually, wherein we'll get a band of white grained or white colored minerals, so followed by the dark colored minerals arrangement in case of gneiss. So this is what for today's class. I think I have taken 2 hours, complete 2 hours now. Surender? Yes, I think today's strength is less.
Yes, sir. Yes.
Probably, I don't know why they had some classes or something.
Actually, the midterm examination was going on, sir.
Okay, okay.
That's why
Yes.
some first year student was not absent. Actually, they have tomorrow morning 2 midterm papers. That's why, sir.
Oh, that's a
Excuse me, sir.
yes.
Sir, tectonic plates lies in lithosphere or asthenosphere?
No. Not in asthenosphere. The lithosphere materials are floating in asthenosphere. It's a semi-solid asthenosphere.
Yes, sir.
Okay, any doubt, anything you can.
Excuse me, sir.
Yes.
Sir, I've studied somewhere that gneiss transforms into schist by a process named as thermal metamorphism. Can you explain something about this process?
Yes, yes.
What thermal metamorphism?
Yes, sir.
Gneiss changes into
Schist by the process of thermal metamorphism.
no thermal metamorphism means it is because of heat. Dynamo metamorphism, thermal metamorphism, dynamo thermal metamorphism. These are the 3 kinds of the process that happens, right? Okay, if that is there, I'll just check it out. I'll pass on this information to Surender.
Okay, sir. Thank you.
Okay.
Okay, sir. Hello. Sir, is it left? Okay, sir.
Yes.
Sir,
Thank
please
you.
give
Thank you
the
very much,
mic,
sir. I would like to thank Dr. S.S.Prakash, sir, Dean, Faculty of Agriculture, College of Agriculture, VC Farm, Mandya, US, Bangalore, for sparing his very valuable time for the welfare of the students. That is almost he has spent on 18 2 hours, and today also he has spared his very important hours. Actually, he is now the Dean of Faculty of Agriculture. There is a lot of work regarding the administrative work. In spite of all these things, due to his spirit of teacher, he has given a very nice information on behalf of the course director, on behalf of this faculty, as well as on behalf of all the students. I am very thankful to Dr. Prakash sir for giving a very nice information, as well as the interactions with all the students regarding the confusion. Always there will be confusion in their mind when they choose any type of object, multiple choice questions. In that way, you have given the proper answer, as well as you have given all the reasons why these 3 are not match to this, the proper answer. That is very nice to see you, sir. This is a very good opportunity for our university that along with us a very nice expert who has a very thorough knowledge regarding the pedology is actually a very complicated or the tedious subject, but you are very masters in that subject. Thank you very much, sir. If Suman, you want to make the thanks.
Thank you, Silkeji.
Yes.
Yeah, please, Suman.
Sir, thank you, sir. Behalf of all the students and all the soil science lover, especially, sir.
Yeah.
They love the soil science. Actually, they're thankful to you and they use the clarity of all these topics in a very beautiful manner, sir. So there's big thanks of you, sir.
Yeah.
No, we are also telling me as a hero innovations, and we are also the big thanks of you, sir. Thank you, sir. Thank you very
Okay.
much. Sir.
Okay. So any time, any one of you can call me for any clarifications. If I do not know, I simply say that I don't know. I'll get back to you quickly. So because I'm under the process of learning still, with all humility that I'll accept it.
Okay.
Yes.
Thank you,
Okay.
sir.
Thank you all.
Thank you very
One
much,
and
sir.
all. Yeah. Have a nice day.
Yes, yes.
Wonderful time. Okay.
Yes.
Thank you. Enjoy.
Yes. Nice to see you, sir.
Okay.
Thank you. Thank you very much, sir. Once again.
Okay.
Suman Kumar, please end the meeting.
Thank you, sir. Okay, sir.